Here we have a full grid showing multiplication results up to 9 times 9. Now, if you are happy with how to use this grid already, that's fine, but if you're a little bit unsure about it and it just looks like a jumble of numbers, then this tutorial is for you. What we've got here is a list basically of the results of what happens when you multiply the numbers which are down here on the left hand side with the numbers that are actually at the top of the grid up here. And the results that we have in here, say, are actually the result of multiplying this number at the start of the row on the left with this number which is at the top of the column that that digit is in. So let's just have a little bit of a look more carefully at that. So imagine that you want to work out 7 times 6. How do we do it? Well, if you find 7 here over on the side and you find 6 at the top of the grid here, and then you draw a line down, you don't actually have to physically draw it, you can imagine it in your head if you want to, and a line across, you'll see where the two lines cross over, that is the result that you're looking for. So if I just get rid of my inky lines there, we should see that the answer to 7 times 6 is actually 42. However, you may have not actually chosen that as your way of figuring out 7 times 6, because there is an alternative method, and that is to circle the 6 up the side and the 7 at the top and do the same thing, and that should lead you to this 42. So you'll notice we had this 42 here previously, and there is another answer of 42 in the grid here, and that is because 7 times 6 and 6 times 7 actually give you the same answer. 6 lots of 7 and 7 lots of 6 come to the same thing, which will greatly cut down on the amount of multiplication results that you will need to remember, which is very helpful. So don't worry if you did it in a different way in your head. You were perfectly correct. That's all fine. Now we're going to work out 8 times 9. And again, there are two ways of doing it. I usually start with the first number over here on the left and the second number up at the top, but you could do it the other way round and that would work perfectly well. And 8 times 9, if you draw your lines across and down mentally, you'll find comes to 72. And that's quite easy. Or if you want to go for the other route, as we said before, let's just change my ink colour, and then we've got 9 times 8, 9 times 8 at the top, circling those. If I look where they come, you'll see they're very close together in the grid, and that's all good. And now let's have a look at one more. We're now going to work out 7 times 7. Now, of course, with 7 times 7, there is only one possible answer. 7 here, 7 there. Doesn't matter which 7 you choose first because the numbers are both the same. So there is only actually one entry for 7 times 7 in this grid. So, and that's true of all the numbers when you multiply them by themselves. And that's quite useful. Okay, so I've just highlighted there all those numbers that have been multiplied by themselves. And I'll just get rid of that circle there. Now then, the useful thing here is that that diagonal, that sloping line of numbers, gives us a sort of split between two sides of this table. You'll notice that if you look either side here of the diagonal list of numbers there, you will see that you have a 2 and a 2 at the top either side. Let me just get my pen going again just to indicate that. You've got a 2 here and a 2 there. You've got a 6 here and a 6 here, and so it goes on. And this is because all of these have come from the same sort of calculation. We've got, for instance, the 12 that I circled last is coming from 4 times 3 and 3 times 4, and those are giving me the same answer, which means in actual fact all these numbers down here at the bottom are just repeats of all the numbers at the top up here. So if that's the case, we can actually get rid of one of the blocks of numbers. We have to keep the green diagonal line in because that only appears once, it doesn't appear twice, but we can actually get rid of a whole load of these numbers and actually reduce again the amount of work that we have to do to learn our tables. So what I call the simple grid actually looks like this, and I've just taken away the bottom corner. You could just take away the top corner equally well. It really doesn't matter which you go for. And it's quite easy to see that all the information actually is still there, but you've got a lot less to learn. So I've just highlighted the 3 times table, for instance, and you can see all the values that were there previously are still there now. And we've just sort of got an L-shaped pattern going on. That's okay. You don't have to know it's an L-shaped pattern of numbers. You just have to know how to use it. So for instance, if you wanted to work out 3 times 6, you would have to use 3 here and 6 at the top. And that would give you your answer here, because 6 times 3, which is this one, times this one, is now an empty cell in the table because we've actually removed that. So it's all more straightforward, really. You really now have only one way to go with it. So just make sure that you're absolutely happy with that. So for instance, if we wanted to work out, let's think of another one. Let's have 8 times 5. Now previously I would have said 8 here and 5 at the top, so you can see that gives me an empty cell, so I don't want to go that way, so I would just do 5 here and 8 at the top. That takes me to the other version of the same answer, and I can see quite clearly that that's 40, and that's perfectly acceptable because multiplication very nicely works in that way for us, so that's really super. Just to show you again the L-shaped pattern that's going on with the 7 times table, you can see all the entries for the 7 times table are still there in that nice L-shaped pattern. But again, you don't need to worry about these patterns becoming L-shapes. It's just something nice to observe. You can now look for shortcuts to help you remember some of the values without doing so much work, and one of the tricks that you can look at is trying to look at things that double up. So I'm just going to highlight some doubles. We've got 8 and 16. 16 is double 8, 20 is double 10, 24 is double 12, 14 is double 28, 16 is double 32, and 18 is double 36. Now why is that happening? Because 4 is double 2, then the numbers in the second row are all double the numbers in the first row that I've highlighted in green. And that's how that works. Now you can find others. See if you can spot some others. If I just give you a minute just to think about that, can you spot any other rows of doubles? There are a few others, and that will help you shortcut things. Okay, well, I've given you a bit of time to think, not a great amount of time, but you can always pause if you want a little bit more time before I give you the answer. But if you are ready, here we go. So if you look at 3 and 6, for instance, and look at the values that you've got there, you've got 18 and 36, you've got 21 and 42, you've got 24 and 48, got 27 and 54. So again, if you know your 3 times table, you can use the fact that the values in the 6 times table are simply double that to figure out values in the 3 times table. So that cuts back on your work. So in essence, what we're actually saying is this, that if you know the answer to 3 times 6, which is here, 18, 3 times 6, then straight away we know the answer to 6 times 6, because this 6 has been made by doubling the 3. The answer is simply double 18, which is 36 if you know your doubles. So that gives you a shortcut way. If you know the answer to 3 times 7 is 21, which you can see in the table there next door, then you know the answer to 6 times 7, because that has been doubled, so you want twice as much, and the answer then will be 42. And that will cut back on the amount of time you spend figuring things out or counting on. which you may find helpful and time saving. So if you use your simple grid, this cut back version of the full grid, to help you with your multiplying, you will get quicker, especially if you do a bit of pattern spotting as well. Good luck and enjoy.